welcome back. Now, we're going to create a simple network, but I want to go back to the old school ages where not a lot of you have the opportunity to kind of get access to the whatever I'm about to kind of share. So let's hope that things will work out. Let's just see what will work and what will not work. So back in the 90s, we had what called hubs, repeaters, party splitters. So I think I'll talk about hubs for now. And hubs were very, very, very popular back in the days. This was equivalent to what we have as switches. So let's have a look at a hub. As you can see, I turn it on, I turn it off. We have what you call LAN backbone supports. It still supports Ethernet cables. You can come and put any other thing that you would want. To tell you the truth, I have not seen anything related to fiber optic in regards to hubs, so I have never interacted with hubs with fiber. I have never interacted with hubs with anything less than an Ethernet port. So I'll just stick to the basics, and as you can continue. But as you can see, you can add some of these components, as you can see. So we need to kind of first of all turn it off. Let's see which is which. Repeater. Let's just assume that we're going to put that. As you can see, then we turn it on. So as you can see over here, we have all that, and let's go to settings and see what we have. Nothing. You can come and rename the hub as, let's say for example, I want to install different offices. Maybe this is the front office hub. Good. Everything looks okay and it's on. And then I'll come over here. You can either rename it over there, or you can also come and double click down here and call it a back office. So if I use that method to actually rename that, so come back to here. If things look okay with you, that's okay. Now the next thing is, as we said in the previous video, this is only used for connection from one to another. So a good example would be if I wanted to connect these two hubs together so that a machine from this side can communicate with a machine from this other side. All you need to do is use a what? Crossover cable. So I'll come and select first Ethernet 0 and first Ethernet 0. As I said, this is a simple network. Now over here, I'll call this a reception laptop. Let's say this is maybe source 1 laptop or computer. This is let's say finance laptop. This is marketing. Let's install. Now we need to connect this to that. So we come copper straight through, connect, come to the next free port. We do the same to this, and as you can see, everything looks rosy because it's green. But there's something I want to see whether you people know. Come and connect that to that, and we are through. Now the next thing is, as I said in the previous, we need to make sure that they are communicating. So how do we do that? We need to make sure that IP addresses are utilized. So in our case over here, let's just sit down and look at what can we do. We have utilized the IP addresses over here. We can come and maybe give it a range. Let's say we talk about having IP address 1, 2, 3, 4. So here I'll come and label this 10.0.0.10 all the way to 10.0.0.20. That's the range I want us to use over here. We can say /8 for now. This is just something random. There's nothing to do with subnetting, it's just random, and it will make sense as we continue why I'm doing this. So each and every one of these devices have an IP address, and as you can see, first Ethernet is up, but IP address is not set. Bluetooth is down also, not set, but the link is up. The only thing about it is these two devices do not communicate. Another way you can actually check whether communication works is by coming to this button over here, click on it, place whatever packet where you want to start your communication, and where you want to end your communication. You'll notice that it says there is no function of box, so let's now configure, because it actually sends that we are not able to communicate. So just a minute. Let's disable this. Let's come over here. I have not set any IP addresses, so let's come over here and use another method of configuring this. So you can either come and also set your IP address over here. I prefer, and I kind of insist, don't use this interface to configure your Ethernet connection, but it depends on what you want. As you can see here, IP version setting is installed. You can come and use this method. We specified that we're going to use from 10 to, so let's make this 10.0.0.10. Then automatically we'll click that. There we go. That is first device, or you can come and do it over here. Where is this? Here at configuration. Let's continue and do the same. You can use any method. Let's use this for the last time. So I'll come over here, click on fast Ethernet 0. That's actually the name that was given. So 10.0.0.11. There we go. We don't need to do anything else. We can now drop this. And you'll notice that something happened before I close that. There was something that blinked. Now, the reason why hubs are important is, one, it just helps necessitate communication from one point to another. It does not use IP tables. What it does is its memory is able to identify what route the network or the devices are communicating from are. So anytime I register these two, you'll notice one thing. I can come over here and come to command prompt, then 10.0.0.11. And you notice communication happens where now I'm able to identify this. Now with hubs, what happens is each port is there's what you call the communication that happens here, where as compared to switches where we have what we call a table that is able to map where each device is. Over here, anytime you connect to a hub, the communication that happens is the broadcasts is usually sent from their machine, because what happens is for communication to happen, there has to be a request and there's someone who's going to acknowledge the requests. So normally in a normal network, once I establish communication and the computer knows I'm 10.10.10, it will always be communicating through that network using what we call broadcast addresses, where I'll be asking, hi, I'm 10.10.10. So the minute I was actually pinging 10.0.0.11, there is what we call a broadcast communication that will be sent from the reception machine to the whole network. Now, at that point, that communication is going to come from this reception computer to the hub. Now, once the hub receives that, it will send some communication out this way, and it will send some other communication this way. The same way, by broadcast. Now, once the 10.10.11 is established, you notice one thing. A response is going to be sent back in the same fashion where a broadcast is going to be sent. Now, the one that went to this other side where that machine or that device is not there, the broadcast will go and it will be duplicated and sent to these other devices. Now, based on that now, you'll notice one thing. If you had like 100 devices, the kind of traffic you'll have over here will deplete the functionality of these devices. So it means there'll be more noise within this network as compared to a network that has a switch. So generally, what happened is this technology was overtaken with time because of the fact that, one, the more devices you attach to this network, the more noise you create, meaning data is going to be slow when it comes to transferring, because you have to also factor in that everybody is communicating with this network. So the more people you actually add to this network, the more the network is going to be compromised in terms of speed and availability. But this was the kind of technology being used back in the days. And you'll notice that I can also come here and configure this, and it should be able to work. Let me call it 10.0.0.12, sorry. Then take note, we are not changing anything with the default servers and the like, so we are going to do that. And then we'll come to the Sales2 laptop and give it an IP address, which will be 10.0.0.14. And we are through. So anytime now I want to communicate with this, I would want to actually show what happens. I can now be able to ping 14. And you'll notice that all of them are blinking. So up to there, I hope you at least understand basically how to create a basic network using Hub. And I hope you learned something, and I hope to see you in the next video. Bye now. So welcome back. I'll try to illustrate this better when it comes to the previous video where I was talking about the hubs and why hubs kind of have a slight disadvantage to switches, and this is what I was talking about. Now, in this case, I want to illustrate how packets are moving from point A to point B. So I'm trying to clear out so that you can actually see its visibility. So come over here, simulation, make sure you click on simulation over here. Then the next thing I want us to do is click on this, and we had actually clicked on this. So I want us to ping 10.0.0.14, and then we see how the packet or data is moving from one place to another. So you notice over here that the requesting IP is here, and what happens is it's able to send a request to the hub. Now this is an ICMP, and you'll notice that it will send it. This hub sends duplicate, as you can see, duplicate packets to each and every area. Once it reaches the place where it's not going to be, it will be rejected. As you can see over here, it was accepted by the IP14. And you'll notice that anytime it hits a hub, it will send that packet to both directions. and you'll notice that it will be accepted where it's necessary, and where it's not going to be accepted, it's going to be rejected. Now, as I was saying, imagine that happens to the reception, sales 1, sales 2, and the finance laptop. You'll find that there'll be a lot of noise where each device will receive what you call requests. And this request, at the end of the day, is like when we're talking about multiple requests. It's as if I tell you, today I will send you a letter, tomorrow I'll send you 2, the other day I'll send you 3. By the time I start sending you 1,000 letters, somehow the 1,000 letters will become overwhelming to you, especially if maybe you're receiving them and you do not have the capacity to. And this is where now we have an issue when it comes to using apps, where it will create what you call a storm. And this storm is able to now make this network not really reliable. At the end of the day, it slows down the network and also makes it inefficient when it comes to communication, because each device is being bombarded by a request, or is trying to send a request to another device as it still receives other requests. So at the end of the day, whatever you had seen over here is just a clean way of actually seeing how data moves from point A to point B. But as you can see, if you have more than 100 requests coming from one device, be assured that the hub is going to be doing more damage to the network than necessary, because at some point you'll find that if you're receiving too much requests, the communication over here will actually freeze, and at the end of the day, communication is not going to be effective. So that's just a summary of the previous video, illustrating what I'm talking about when it comes to the reason why hubs were used once and kind of were removed out of production, based on the fact that, one, they were not as effective as the switches, and whatever is actually now out here is because, one, there was a lot of noise within the network. So there's I keep forgetting the word that is used in CCNA, where we talk about there's what is called storms. There's a storm that is going to happen out, collision storm that will happen within the network. So anyway, next we are going now to talk about the different other devices that we'll be working with, and hope we at least give some idea of why. Hope I've given you some good ideas of how networks are, and see you in the next video.